Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe the effect of temperature and pH on enzyme activity. We've been looking at enzymes. We saw that enzymes speed up chemical reactions, and to do this, they've got a groove on their surface called the active site. The substrate is the molecule that the enzyme reacts with, and this fits perfectly into the active site like this. The enzyme now breaks down the substrate into the products. Remember that enzymes are specific, and that's because the substrate must fit perfectly into the active site. That's called the lock and key theory. So we're going to start by looking at the effect of temperature on the rate of an enzyme-catalyzed reaction. I should point out that this is a very common exam question, so you need to learn it. Imagine I've got an enzyme-catalyzed reaction, and I gradually increase the temperature. At each temperature, I measure the activity of the enzyme, in other words, the rate of the reaction. I get a graph that looks like this. As you can see, as we increase the temperature, the activity of the enzyme increases. In other words, the reaction gets faster. That's because as the temperature increases, the enzyme and the substrate are moving faster. That means there are more collisions per second between the substrate and the active site. At a certain temperature, the enzyme's working at the fastest possible rate, and that's called the optimum temperature. At this point, there's the maximum frequency of successful collisions between the substrate and the active site. For most human enzymes, the optimum temperature is 37 degrees Celsius, which is human body temperature. Now, as we increase the temperature past the optimum, then the activity of the enzyme rapidly decreases to zero. In other words, the enzyme stops working. That's because at high temperatures, the enzyme molecule vibrates, and the shape of the active site changes like this. Now the substrate no longer fits perfectly into the active site. We say that the active site is denatured, and you'll be expected to use that word in your exam. The enzyme can no longer catalyze the reaction. Okay, let's take a look now at the effect of pH on enzyme activity. In this case, we're taking an enzyme-catalyzed reaction and we're altering the pH. We're then measuring the activity of the enzyme at each pH, in other words, the rate of the reaction. We get a graph that looks like this. The enzyme has an optimum pH where the activity is maximum. If we make the pH more acidic or more alkaline, then the activity drops to zero. That's because the active site denatures if the conditions are too acidic or too alkaline. Each enzyme has a specific optimum pH. So for example, this enzyme works best at an acidic pH. This could be a protease enzyme in the stomach. This enzyme works best at an alkaline pH. This could be an enzyme released from the pancreas into the small intestine, for example lipase. Remember, you'll find plenty of questions on the effect of temperature and pH on enzymes in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to describe the effect of temperature and pH on enzyme activity.